Antarctica is changing very rapidly. What we're trying to do is understand how cracks grow and predict the timing of these big calving events. It has the potential to raise sea levels by tens of meters, so this will quickly have a direct impact on coastal ecosystems, mass migration, and for society as a whole.
The Rift Tip project is about trying to understand the rate and timing of why ice fractures and why we get these large icebergs produced from ice shelves. If we can't understand how and when ice fractures and produces icebergs, we don't really understand how much sea level rise is going to be caused by ice shelves.
What the whole project is designed to do is fill in the gaps between understanding what's happening at the small scale with crack growth and the large scale with iceberg production.
We think it all comes down to centimetre, millimetre ice crystal scale of where that crack goes. It's such a small process that we're trying to understand with all this large equipment and these large expeditions.
When we're in the field and drilling the ice, it's quite an exciting process.
We need the cores to be in a real pristine condition. They can't have any fractures or anything in them that we've created.
Then it has to be taken back to Halley, then loaded onto the Sir David Attenborough ship.
It's a long process, so we had to wait around 9 months to see the ice again. So if you melt this ice, you'll hear it bubbling. Different types of chemistry that could be to do with the amount of sea ice that was present in Antarctica at that time of year. It could be to do with volcanic activity, and we use all that to both understand the chemistry of the climate in the past, but also age our ice. We want to understand why it is that when ice fractures, it goes through certain types of ice more so than other types of ice.
What controls the strength of a material is the things that are within it. So many things that are crystalline essentially have a grain size. And the grain size is a primary control on how things break.
When we put the polarized paper on, we can really clearly see the crystals. It looks like magic, doesn't it?
What we then do is test how does the ice fracture as a function of depth.
It's moved about a centimetre in 1/18,000th of a second. You're talking about rupture tip speeds there of approaching 1 kilometre per second, so really, really fast.
There's clearly different aspects of the ice structure, some things that we know and some things that are completely new in terms of variations of strength, which is really going to help us in terms of feeding that into the larger scale models.
We're essentially getting the missing pieces of the puzzle. We can run the model forward in a predictive way and find out what the future behaviour of this particular ice shelf will be.
We need to do this research. We have to go to Antarctica and collect this data and model Antarctica to be able to understand how it's changing, to have an impact and make a change.
We need to be as certain about numbers that we're providing such that there's no excuse not to do anything.